So let us read this problem. So this says we have a heavy box sliding without friction down a smooth plane of inclination theta. So this is a smooth plane we have. So there is a smooth plane, and this plane makes an angle theta with the horizontal that is given to you. Now from a point P on the bottom of the box, a particle is projected inside the box. So you have a point P on the bottom of the box. There is a particle that is projected inside the bottom of the box. Inside this box, this particle is projected. Now the question says the initial speed of the particle with respect to box is u, and direction of projection makes an angle alpha with the bottom as shown in the figure. So this is projected with a speed u, and this projection makes an angle alpha with the inclined plane. Are you getting or not? So what you have, so you have been given u, that is the velocity of projection. So velocity of projectile with respect to box, that is important. So velocity of projectile, so this is given to you. So velocity of projectile, and this is with respect to box. Are you getting? Now the question says, first part of the question, alpha is also given to you. So alpha is given, and theta is also given, that is inclination angle of incline. Find the distance along the bottom of the box between point of projection P and point Q where its particle lands. So we have to find distance between point of projection and point of landing, and assume that box is sufficiently large and you have to neglect the resistance. So you see what we will do. Let me modify this problem in a sketch. So what we have, so we have a something kind of this kind of thing. So this is my inclined plane, and this makes an angle theta with the horizontal. So this angle is theta, and here this particle is basically thrown at this point inside the box, of course, and this velocity, this angle is alpha. Now this will follow this kind of parabola. Are you getting or not? This kind of parabola it will follow, and it will land at a point Q. So it will land at a point Q. So let us say this point is Q. And what I will do is, to solve this problem, I will change my coordinate system. So let us take this is my y coordinate system. So if I take this as a y coordinate system, sorry. So this is perpendicular to this incline, slightly difficult to make. So this is my y axis, and this incline is my x axis. And now what I will do, I will try to write what is the g. So g is this, and let us say this is the perpendicular to this incline. So what is this angle? Can anybody tell me what is this angle? You can tell me this angle. If you know angle between line is equals to angle between perpendicular. So if you follow that, you can tell me easily. So this line perpendicular is this line. This line perpendicular is this line. So this angle is theta. So angle between line is equals to. So component of z along this direction, that is my x-axis, choose in y-axis. This is z cos theta. Are you getting? So what I have to do is, I have to break my acceleration. That is one important point we have. And if I have to have acceleration in this direction, component of acceleration in this direction, that is z sin theta, in this direction g cos theta, in this direction I will have g sin theta, in this direction you will have g cos theta. Now finally particle landed here. We have to find distance along the incline. So what we have to find, what is the distance? Let us call this point is O or P. So let me see, this point is P, I think, yeah, this point is P. This point is P. So what we have to find, so let me write P again. So this point is P here. Now what is the thing we have to find, that is distance along incline, that is PQ is what? This is my target. How will proceed? So to proceed for this equation, what we can do is, we can write equation in this direction, and equation in this direction. So if I write s is equals to ut plus half at square, ut plus half at square, let us say in the bidirection. So what is the distance traveled in the bidirection? Initially y coordinate is 0, finally y coordinate is 0, so in the direction of y there is no distance traveled. What is the initial velocity in the y direction? Initially it is thrown with the speed u. Are you getting or not? And this distance we have to find with respect to the box. So I have to find pq, and this is with respect to box. So another important point we have, I have to take u, that is the velocity with respect to box, acceleration with respect to box. This is important point we have, acceleration with respect to box and velocity with respect to box. This is the two important point we have. So you see, this is all with respect to. So this is s is also with respect to. So this is with respect to box. Are you getting or not? This is again with respect to box. This acceleration is all with respect to. So let me explain again. So this is s. This is with respect to box. This distance is how much? This distance is 0 because in the bidirection. So I am writing equation in the bidirection. In the bidirection there is no distance travel. What is the u with respect to box? So u with respect to box. And that is given in the problem. This is u only. So this question says this goes with the speed u with respect to box, but in the bidirection this is u cos alpha in the x direction. In the bidirection you will have u sin alpha. Are you getting? So with respect to box in the bidirection you will have a velocity u sin alpha. But in the acceleration with respect to box in the bidirection. Now the box is not moving in this direction, bidirection box is not moving. But in the acceleration of the this stone or this projectile in the bidirection, this is basically a free fall case. So acceleration will be g cos theta, but this is a negative by side. So I have to write this as minus g cos theta. This is the only important point we have in this problem. Now put these values. 0 is equals to ut, that is u sin alpha into t, plus half at square, that is a is minus, so minus half g cos theta into t square. So if you solve for t, so you will have 2u sin alpha, and this divided by g cos theta is equals to t. Now if I have, this is the time of flight, you can say, what is the distance traveled in the x direction? So now I have to write equation in x direction. So this equation we have written, all these equations we have written in the y direction. Now if I write equation in x direction, what I will have, x equals to, I have to find pq, that is s is equals to ut plus half at square. Again I have to apply ut plus half at square. Now s is basically pq, so I have to find pq. Initial velocity in x direction is u sin alpha, u cos alpha. Let me write the same thing again. So x, distance with respect to box, I will go fast. This is equals to pq. This I have to find. X speed with respect to box, and this is simply u cos alpha because you have in this direction component is u cos alpha. And now acceleration with respect to box. This is slightly important. Now box is again free fall. Box is kept on a frictionless plane. So now see, the box is in this direction. Box is itself falling with g sin theta, and the projectile also have g sin theta in this direction. So what is with respect to box? What is the acceleration of projectile in this direction? No acceleration. Both are falling with g sin theta. So this is 0. This is one important point we have in this problem. So you will have 0. So u into t plus half at square, acceleration is 0, and in place of u, you have u cos alpha, and t you have already calculated from part 1. So this is the time 2u sin alpha divided by g cos theta. Are you getting? So this divided by z cos theta. So what is this value? So we will have 2u square. So u square sine 2 theta, that is u square sine 2 alpha. This divided by z cos theta. Are you getting or not? So this is the value of x you have. Now let us discuss part B. So what this B part of the question says? So B part says, if the horizontal displacement of particle as seen by the observer from the ground is 0, horizontal distance in this direction from the ground. So now I have horizontal distance is 0 with respect to ground. Find the speed of the box with respect to ground at the instant when the projectile was projected. So what we have this time? So this time question says, what is the speed of box? We have to find a speed of box. So with respect to ground. So this is a speed of box. So we have to find a speed of box. And this is with respect to ground. Are you getting or not? So this is with respect to ground. So we have to find what is the speed of box with respect to ground. Initially, let us say this box was initially going in this direction with velocity v. So this is the initial velocity of box. Question says there is no displacement in the x direction from the ground. There is no displacement in the x direction from the ground. And if you see from the ground, there is a, what is the velocity in the x direction? You have this a stone or this projectile has two velocity in the x direction. One velocity is u cos alpha. So let me put again. So let me make the diagram again. So you have here, and this projectile is projected with angle alpha, and this angle is theta. So this angle is theta. So initially, what is the speed of this stone or this projectile in horizontal direction? That is u cos alpha plus theta. So this is the initial speed you have. Now question says this is the speed of projectile with respect to box. So this is with respect to box. Are you getting or not? But box itself has a velocity in this direction, and this velocity is v. So what is the velocity of box in this direction? Can you calculate this one? So if this in this direction your velocity is v, so this is v, and this angle is, you can calculate, this angle is theta. Are you getting or not? So in this direction you will have a speed v cos theta. So in this direction you will have v cos theta. So what is the speed of projectile in the x direction with respect to ground? So let me write. So a speed of ball with respect to box, and this I am writing in x direction, is what? U cos alpha plus theta. Are you getting or not? And now what is the speed of ball? No, not this ball, not, it's a box. A speed of box with respect to ground. So this is what? You have v cos theta. I am writing in the x direction. So now if I ask a speed of ball with respect to ground, then I have to add these two velocity. One is this side, another is this side. So basically I have to subtract. So v cos alpha plus theta minus, this is u cos alpha plus theta. So this is u, not v. So this is u cos alpha plus theta minus v cos theta. Are you getting? Another question says total distance traveled in the x direction is 0. So if I apply s is equals to ut plus half at square again, so what we have? Total distance traveled is 0. What is the velocity in the x direction? That is u cos alpha plus theta minus v cos theta ut plus half a t square, and now you know this relation is 0 in this direction, so this is simply 0. So if I solve, what we will have? So we will have v is equals to u cos alpha plus theta. So this is u cos alpha plus theta, and this divided by b cos theta. Are you getting? Simple. So this is the initial velocity. No, v. So v is here. So I should have to remove this v here. So this is the final velocity. This is the velocity of box with which it was going downward direction.